All right, welcome to your at-home virtual learning lesson. This one's going to be law of cosines. Before I start this, I'm going to recap all of the other patterns that we've done so far. So we did angle, side, angle, and angle, angle, side. Those ones are just law of sines. So those are literally just do the problem. Then the other one we did was side, side, angle. That's the one with the analysis and that whole flow chart that you have to do. So theta is obtuse, theta is acute. Sometimes you get no solution, sometimes you get two solutions, sometimes you just do the problem like this. But that's the one with the analysis. So today we are going to do side, angle, side, and side, side, side. So this is going to be the law of cosines. So these are the two that we're going to do today. So this is your law of cosines. It's a little bit longer, so don't freak out when I write it. And there's three kind of sort of like versions of it. So a squared equals b squared plus c squared, and those are all lowercase, so they're sides, not angles, minus 2bc cosine of a. So here's how you can remember this, because I know that that looks like a lot. Do you see how this is b and c? They get repeated right here. So whatever these two are, that's what these two are. They're all sides. They're all lowercase. And then do you see how this is side A? This is angle A. So these two kind of match, if you want to think of it that way. So these two get repeated, and then these two match. Believe it or not, memorizing this actually goes really, really well. The most common mistake I see with it is people put sine instead of cosine. And I'm like, guys, it's the law of cosines. So just be careful with that. Now, you can scramble the letters, though. The letters don't matter. I mean, it could be triangle LMN as well, you know? So another version of it would be b squared equals a squared plus c squared minus 2ac cosine of b. So see how these two repeat right here, and then these two match. And then if you look at it the third way, it would look like that. So again, these two get repeated right here, and then these two match. So I don't want you to think of those as three totally separate pieces of information. They're all the same thing. It's just if the triangle gets scrambled around, you can look at a different version of it. So let's go ahead and draw our first triangle. Start at the bottom left is A, which is 61. I don't have little a. And then B, little b is 4, and little c is 6. So our pattern here is side, angle, side. The angle is in between the two sides. So that tells us law of cosines. Again, the pattern tells you what to do. So if it's side, side, angle, that's that analysis. If it's one of those first two that we did, it's law of sines. Here we got side, angle, side, so it's law of cosines. So the pattern is what it tells you what you're going to do. So let's list out what we are missing. We are missing side A, and I know usually we find all the angles first, but we're going to have to find this first because it's across from the one angle that we have. So I know usually we find all the angles first, but you have to find little a first in this case because it's across from the only angle that you've got. And then out of the other two, we're going to find them smallest to biggest. That is important here. So make sure you do smallest first. So that would be angle B, which is across from the 4, and then angle C, which is across from the 6. So we are looking at the first version I wrote of this. Again, they all mean the same thing. It's just we have angle A, 61. So this has to be the version that we're looking at. So it's going to be a squared equals 4 squared plus 6 squared minus 2 times 4 times 6. Again, those just get repeated right here. Cosine of the only angle that you've got, which is 61. So to get a by itself, to get rid of the squared, we're going to square root. And so what I'm going to type in the calculator is square root of all of that. And let me just make sure I have the calculator up, which I do. So we're going to type square root, which you can type SQRT, or you can go in here and get the square roots right there. So it is 4 squared, which is 16, plus 6 squared, which is 36, minus 2 times 4 times 6. You could do that part in your head too. Cosine, oh, I just remembered I need to change to degree mode. Cosine of 61. And so we get 5.359. And so that I can reuse this answer later, I'm going to write A equals so that I have it. So that's what we have there. Now, because we have A and we have a side across from an angle, we can do law of sines, which is a lot shorter than law of cosines. So I'm going to have A over sine 61, these two across from each other. I want to find B next. So I want to have 4 over sine of B. So I'm going to cross multiply and divide by A. I have A stored in the calculator. I'm trying to find angle B, and I need to do sine inverse because I'm looking for the angle. So I need to undo this sine that's here. So I'm going to do sine inverse and then do cross multiply and divide. We've done that before. You guys did that with the pattern SSA. So I'm going to go in here and get functions. I want sine inverse. And I'm going to type 4 sine 61 divided by little a, which I have right here. And when I type little a, it's plugging it in for me. So 40.745. And then now that I have angle A is 61 and angle B is 40 point blah, 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 I can just subtract from 180 to get angle C. So I'm going to make sure that it has, that my calculator has this equaling angle B, and I'm going to do 180 minus 61 minus angle B, and that gives me what's left for angle C. So 78.254. And I'm going to clear all this out before I start a new problem. So let's try that again. I realize this is 121. You can draw an obtuse triangle, of course, if you want. I don't view it as worth it. I just draw something with 3 sides. So that's angle B. I don't have little b. A is 5. C is 3. And again, I have side angle side. So I know usually we find the angles first, but I have to find little b first in this case because it's across from the angle that I have. Now the other angles you have to find in order smallest to biggest. So we're going to have to find C first and then A. So the version of this that I'm using to get little b is this second version of the formula, but again, they all mean the same thing. So b squared equals 5 squared plus 3 squared, whoops, minus 2 times 5 times 3. So again, these just get repeated right here. Cosine of the only angle you have, which is 121. So again, to get b by itself, we're going to square root all of that. And let me type that in the calculator. Right, so I got 7.032, and I want that to be stored as little b. So now we have little b, we have a side across from an angle, so we can do law of sines, which is better because it's a lot shorter. So b over sine of 121, and I'm going to do c next because this is the smaller one. So 3 over sine c. So I'm going to hit second sine to cancel out this sine. I'm looking for the angle, so I'm going to do sine inverse and then cross multiply and divide. All right, so I'm going to go into functions, sine inverse, and type 3 sine 121 divided by little b, which it's copy and pasting for me because I have little b right there. So 21.449. And that is angle C. So now that I have angle C and angle B, I can subtract from 180 to get angle A. So 180 minus 121 minus angle C. So A is 37.550. So that is how it turns out when it is side angle side. When you look at this one, basically the only reason you're going to draw a triangle is because I'm going to give you points for it. This is very obviously side, 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 and it kind of doesn't even matter where you put any of these because you don't have any of the angles. It is nice to have a visual, I suppose, but side, side, side is your pattern. And we're going to start smallest to biggest. Again, it's important now. So you want A first. And then C is the next one, and then B. So if we want angle A, and just as a heads up, this one is a little bit more steps. It's more work than this was. Like here, for side angle side, you just set this up, type it in the calculator. Set this up, type it in the calculator. This one's going to have a little bit of work, just as a heads up. So first, if we want angle A, we're going to need this version of it, like start with A. So little a is 4. So we're going to have 4 squared equals 10 squared plus 8 squared minus 2 times 10 times 8 cosine of A. So this would be 16. This would be 100 plus 64, so 164 minus, oh gosh, 2 times 8 would be 16 times 10 would be 160 cosine A. The most common mistake that I get is people subtract 164 minus 160. You can't do that because they're not like terms. This is 160 cosine of A. This does not have a cosine of A with it. They are totally separate terms. So instead, what you're going to do is subtract over the 164. It is going to give you a negative number. It's going to be negative 148. But that is okay because on this side, you're left with negative 160 cosine of A. This is how it will turn out every single time, is you will get a negative on this side and a negative on this side, and they will cancel out. So your next step is to divide over the negative 160. I realize that reduces, but I don't really care because I'm going to type it in the calculator anyhow. So you get 148 over 160 equals cosine A. And so the way that I'm going to type that is with cosine inverse. So here, let me clear out all of this. I'm going to go into functions. Let me get cosine inverse, 148 divided by 160. And so we get that A is 22.331. And I'm going to go ahead and store this, oops, as capital A. So now that you have angle A, you have a side across from an angle, which means you can do law of sines, which is better because it's way shorter than all of this now that you have angle A. So we're going to do 4 over sine of A equals, and then the next one we're finding is C. So it's going to be 8 over sine C. So we're going to cross multiply and divide by 4. But since you're looking for an angle, you need sine inverse. So it's sine inverse and then cross multiply and divide. So sine inverse, and then it is going to be 8 sine of angle A divided by, oh, whoops, I don't the whole thing. Divided by 4. And so we get 49.458. And then once you have angle A and angle C, you can just subtract from 180 to get the last angle. So I'm going to store this one as C. And if you do 180 minus A minus C, that's going to give you B. So 108.209. So let's try that again. This is obviously side, side, side. That's the easiest one to identify. And kind of the only reason you're drawing a picture is because I give you points for it. Oh, and I'm remembering this one now. Do you see how I made these the same? I did that to try and give you a break. So you need to find these smallest to biggest. So either C or B first, it doesn't really matter. They're actually going to come out to the same thing. If side B and side C are the same, then, or congruent, to use good vocabulary, then angle B and angle C are also going to be congruent. So those are going to be the same. So it doesn't really matter which version of this you use. And again, these all mean the same thing. I'm going to just find B first because of, alphabetical order. So 10 squared equals 10 squared plus 12 squared minus 2 times 10 times 12. Again, these just get repeated. Cosine of B. Now you have to actually work this out. So that's 100. This would be 100 plus 144, so 244 minus 2 times 12 is 24 times 10 would be 240. Do not subtract these together. They're not like terms. Instead, you're going to subtract the 244 to the other side. It will always turn out negative, but that's okay because this side will always be negative. That is just always how it's going to turn out. And then the negatives will cancel. So you end up with 144 over 240. And again, I know that reduces, but whatever. Cosine B. So the way I'm going to type that, I'm trying to anchor this, but the paper is not going to stay there. It's going to just fall. So we're going to type cosine inverse. Let me get rid of all this. I just always like to start fresh. I know I could change the stuff that's there, like just alter it a little, but I don't know. I like to just start all over. 144 over 240. So that is 53.130. I'm going to go ahead and store that as B. And because, again, side B and side C were the same or congruent, angle B and angle C are also congruent. So to get angle A, you just subtract from 180, but you just subtract this number twice. So it's going to be 180 minus, you can either do minus B and then minus B again, or you can do minus 2B, whatever suits you. But 73.739. All right, that is your law of cosines. I threw these on here to just review our area formulas. So for this one, you know what? I actually wanted to change this. I didn't want to give you two angles and a side. I wanted to give you two sides and an angle. Looking back at my notes here. So let me change this and give you side A. I just wanted to review the formula. It can be 1/2 AB sine C, or then you can, jumble the letters. In this case, that's always the one I think of first because it's ABC. So that's how my brain just remembers it. But if you have angle B, you can do 1/2 AC sine of B. The third version would be 1/2, would be BC sine A. You can just, jumble the letters around. So if we're looking for our area, in this case, it's going to be 1/2 times 5 times 7 sine of 35. And I'm going to just go type that in. So 10.037. And I didn't put units on here, but say I had put, centimeters, it would be centimeters squared. It's squared for an area. And then if all you have are sides of the triangle, so you don't have an angle at all, it's that Heron's formula. So there's that S value. It's 1/2 of adding all the sides together. So you add all the sides up and do a half of that. So let me just type that in. So 17.5. And then to get the area, you do this gigantic square root, and underneath of that, you put that 17.5. And then I usually just draw 3 more blanks. You do 17.5 minus each of these. So 17.5 minus 9 would be 8.5. 17.5 minus 11 would be 6.5. And 17.5 minus 15 would be 2.5. And you type that in and magically you get the area. I actually really like this formula because I just think that's so cool that that works. That you can just take all the sides of the triangle, like any triangle, and this will work. So 49.164. And again, if there were units given, it would be squared. And then the last thing that we're going to look at are bearings. This is how to do word problems that involve bearings. So you start due north and rotate clockwise. So if you're ever, on a ship in the ocean, I guess this will help you. So you start due north and rotate clockwise. So the way it's written is like this. A and B are 10 miles apart. The bearing of B from A. So you start at A and you're going to B. The bearing of B from A. So this is like how to get from A to B. So here is A, point A. This is due north, so straight north. And we're going to rotate clockwise 60 degrees. So you start here and you rotate clockwise, which is, this direction, 60 degrees. I'm not going to get out a compass and measure this, about like that would be 60 degrees. And so B is over here, 10 miles away. So it's like giving someone directions how to get where you are from where they are. So let's just try it again. A and B are 5 miles apart. The bearing of B from A. So you're trying to get from A to B. The bearing to get to B from A is 290. So a full circle is 360. You're going to practically go the whole way around. So here's A. This is due north. And so again, we rotate clockwise. So if you were to rotate, 360 degrees, that would take you the whole way around. You just only go 290. Try to spin this a little bit better. So you're gonna only go 290. So it's gonna be sort of like in a this way-ish direction. So 360 minus 290 would give you 70. Like all of this was the 290. Let me get that where there's no glare. So all of this is your 290. If you go 70 more, that would be 360. So B is in like a this way direction. And they are 5 miles apart. So this distance, you would go 5 miles and then you would get to where you're trying to go. So here's a problem where we kind of put all of that together. Martha lives on one side of a river. Jim and Ted live on the other side. The river is 100 yards across. All right, so here is one side of the river. Here is the other side. Martha lives on this side. This is due north. So this is, 90 degrees here. That's due north. And the river is 100 yards. Oh, wait, was it yards? I thought it was yards. Yeah, it's 100 yards across. So now let's get our bearings. The bearing of Ted from Martha. So if you're trying to get, from Martha to Ted, Ted from Martha is 125. So if you start at Martha here and you rotate, running out of space. If you rotate 125, Ted is going to be like in a this way direction. So this is Ted. So 125 is this whole amount. 125 minus 90 is going to give us 35. So that's going to be 35 for this angle right in here. So that means this is also 35. So alternate interior, those are going to be congruent. So again, this whole thing is 125. If this part is 90, this part has to be 35. All right, the bearing of Jim from Martha. So if you're trying to get to Jim from Martha is 210. So we're going to start due north and go 210, which is going to put, what was his name? Jim in a this way direction. And so we want to go 210 degrees. So if we rotate to here, like we start due north and rotate to due south, that's 180. And then you would go 30 more to go to 210. So from up here all the way around to here, I don't want to make the picture too cluttered, but it would be this much would be our 210 because a straight line is 180. And so to get to there would be 210. So if that's 30, and this is our right angle, that would make this 60. And then our alternate interior, that would make this 60 as well. And this, of course, is a right angle. This is our 100 yards across the river. All right, so what we're trying to figure out is how far Jim and Ted live apart. So I'm going to call this A and this B. We're going to do two separate problems, find A and B, and then add them together to get this whole distance. So let's look at Jim's triangle first. If this is our 60 degrees, our opposite is 100, and our adjacent is A. So opposite and adjacent means tangent. So we're going to have tangent of 60 equals 100 over A. So the way that you would type that in is 100 divided by tangent of 60. So that is 57.735. And to make the calculator store that for me, I'm just going to write A equals so that I can like do a copy paste. So now if we do B, same exact thing over here. If this 35 degrees is our point of view, opposite is 100, adjacent is B. So it would be tangent of 35 equals 100 over B. And so I'm going to type the same thing, 100 divided by tangent of 35. So it comes out to 142.814, and I'm going to make that store as B. And to get the total distance between Jim and Ted, we're just going to add those together. So A plus B. So I'm going to go back to my calculator. And I'm going to do A plus B. It'll copy paste them in there for us. So 200.549. And it was yards is our final answer.